In this video tutorial, I will explain to you the meaning of ions, the meaning of an ionic bond, a covalent bond, the type of covalent bonds, and how to know if a bond between two atoms is ionic or covalent. So first of all, we begin by explaining the difference between an atom and an ion. An atom is a neutral particle in which you have the number of electrons is equal to the numbers of protons present in the atom. So the number of electrons is equal to the number of protons. And usually an atom, next to the symbol of the atom, you will not see a plus nor a negative. Like for example, H, O, Cl, Br, N, and etc. All these presented atoms, they are neutral. The number of electrons present in every atom is equal to the number of protons present in each and every given atom in this example. Now, how an atom can become an ion? An atom have two options. The atom will either lose electron if it was a metal, and it becomes a positive ion, and at this point you start calling it an ion, and specifically a cation. Or an atom, if it was a non-metal, it will gain electrons, and in this case it's going to become a negative ion. And what we know, the name of a negative ion is anion. So recap: an atom can either lose or gain electrons. The atom is neutral. If the atom lost electrons, and if that atom was a metal, it's going to become positive, and we call it a positive cation. If the atom gained electrons, it's going to become negative, and you call it anion. Now, how the bond is formed, and specifically I am going to start talking about the ionic bond. An ionic bond is the force of attraction. It's the electrostatic force of attraction. Ionic bond is an electrostatic force of attraction between oppositely charged ions. Between oppositely charged ions. So for example, if I have an A which is positive and Cl minus which is negative, the positive and the negative are going to attract each other, and this force of attraction is called ionic bond. So this is the definition of an ionic bond. So always, to form an ionic bond, you need to make it between any metal and a non-metal. So any selection here of an atom colored blue with an atom colored yellow will give you an ionic bond. And usually in the ionic bond, the metal transfer electrons to the non-metal. So the metal becomes positive and the non-metal becomes negative, and then they start attracting. Now, again, let's look at another example. Here, metal atom A, which must be a metal. So for example, I'm gonna take magnesium or lithium, and boron is a non-metal, so it could be a fluorine non-metal. Or another example, let's take another example, sulfur is a non-metal. Here's F and here's S. Here's their location in the periodic table. Whereas magnesium and the other element that I selected, lithium, are both metals. What's going to happen in here? Magnesium is going to lose electrons and transfer them to fluorine. Magnesium is going to turn positive and fluorine is going to turn negative. Now, why magnesium plus 2? Because magnesium is going to lose 2 electrons. It's in group 2. And F will gain 1 electron each F. So here magnesium is going to transfer electrons to 2 atoms of F. Each one will become negative. So here 2F atoms. I'm going to write it twice. Every F will take an electron. This is how it looks like. I'm going to draw it in a better way. Here's magnesium having 2 valence electrons, and here's F. That's the first F having 7 valence electrons, and that's the second F. So magnesium will transfer the electrons to F. Magnesium will turn positive and each F will turn negative. Oppositely charged ions, they attract each other and they form the ionic compound MgF2. The overall charge of this ionic compound will become 0. Now let's look at the second example, lithium and sulfur. Lithium belongs to group 1, it's a metal, it is going to lose 1 electron, while sulfur belongs to group 16 and it should gain 2 electrons. So what's going to happen, first lithium atom will transfer electron to sulfur, and then another lithium atom will transfer another electron to sulfur. Like this, we are going to have 2 lithium ions with 1 sulfur anion. They are oppositely charged ions. They are going to attract each other and they are going to form lithium sulfide. Now the overall charge of this ionic compound becomes 0 because we have 2 positive with 2 negatives. Now let's move on to the covalent bond. Covalent bond involves sharing electrons and not transferring electrons. And to form a covalent bond, we only need non-metals. So for example here, it's not the combination of metals. We need non-metals together. And sometimes also we can take the metalloids with them to form a covalent bond. So these atoms, the non-metals, they share electrons. They share their electrons. So look at atom A and atom B. Both of them are nonmetals and they both share these electrons. And like this, they form a covalent bond. Now, we have 3 categories of covalent bonds. The bond could be single. When the atoms share in common 2 electrons, the bond is single. When they share 4 electrons, the bond is double. When they share 6 electrons, the bond is triple. This is how we usually represent the bond. One line, one pair of electron is for single bonds. 2 lines, or what we know, 2 pairs of electrons is for double bonds. Remember, 2 pairs of electrons equal 4 electrons shared. 4 electrons shared. Now for triple bonds, it is always represented by 3 pairs shared, which is equal of 6 electrons shared between A and B. Now let's do a quick question. We need to determine whether the given compounds are ionic or covalent based on their formula. So let's take the first example. In order to know if CO2 is ionic or covalent, I need to locate the atoms and to see if C is a metal or a non-metal. So both of them are non-metals. So if the both atoms are non-metal, it means that this compound is covalent. C and O will share their electrons. Let's look at the second example. Sodium and chloride. Sodium chloride. Sodium is a metal, Cl is a nonmetal, so this compound is ionic, and NaCl will transfer. Na will transfer electron to Cl. Similarly, Al, metal, and oxygen nonmetal. So this one is as well ionic. Now let's look at the next example. Hydrogen, it's located with the metals, but hydrogen is a non-metal. And O again is a non-metal. So here's a covalent bond. Now C and H4. C and H, both of them are non-metals, so this compound is also covalent. P, F3, also covalent because both elements, the P and the F, are non-metals. Li and O, Li and oxygen. So one metal, one non-metal, that is ionic. Now zinc sulfide, Zn and S, metal and non-metal, so this is also ionic. Thank you.